Hello and welcome back. Here I am, learning to do some of the basics in the Unreal Engine. So just waiting for the Unreal Engine to fire up right now. But basically you can see that we're on part 4 of our tutorial. Which will be adding character animation. So right now we just have basically a T-pose human model in our first-person shooter game, and we have I guess the arms for the first-person view, but we have not added any animation. So we will mess around with the rigging on the character static meshes. Excuse me. That is, again, once we get the Unreal Engine to actually fire up. I don't know what it's doing. In the meantime, how's it going? Hope you're having a good Tuesday so far. Just waiting. Waiting for Visual Studio to start responding. Waiting for the Unreal Engine editor to pop up. I swear it's gonna start soon, right? Oh, there it is. Assets were open when the editor was last closed. Don't restore. So let's start off by showing off what we have right now in our game. So this is one of our other levels that we were working on for a different tutorial. But let's open up the map for the FPS. Looks somewhat similar. We have a little platform that we can walk around on. We have 3 boxes that we can kind of jump around, and we also have this white box that we can actually shoot. Welcome back. I see you there. Tcluidg. TCLUIIDG. So let's play this in the editor. So as you can see, we just have our straight arms out in the in our camera's view, but we can walk around. We can shoot. We have a crosshair on our HUD right now. We could have bullet collisions and physics going on right now. We can jump, stuff like that. It doesn't look great right now. You know, it's very bare bones. So let's start on with the tutorial, I guess. Alright, so the goal of this section is to show how to add animations to the first-person character. By the end of the section of the tutorial, we'll be able to animate the character, set up our event graph, add an animation state machine, add transition states to our animation. Excuse me. And associate the animation blueprint with the character blueprint. So it looks like there's a few steps here. 5 in total, but there's a big portion for 4.4. I've never messed around with animations yet, so this will be very interesting part of the tutorial. Okay, during this step, we're going to get some animations into our game. So we need to download this set of sample animations. So let me get that figured out right now. And we have, looking at the tutorial, we're going to create a new folder in the game editor. Once I get our animations in there. Hold on. Almost there. And in here. Okay. I've placed our animations in the right location. So let's go into the content browser and make a new folder. They want us to name it animation. So I'm going to put in the assets folder and just say new folder, animations. So there it is. Let's go into it. And then okay, so it wants us to put the 5 animations into this location. And that's these FPP files. We have idle, jump end, jump loop, jump start, and run. Okay. That's all 5 in here. So it wants us to select a skeleton mesh. And we have the hero FPP skeleton. Alright, and that's all we need to do, so we can import all. So now we have all 5 animations inside of this animation folder. Interesting. Alright. So let's click the save button to save those imports. So creating the animation blueprint. Click the add new button and select animation blueprint. Go to animation, animation blueprint. Select anim instance. Okay, it's right up here. That's a parent class, I guess. And choose game hero FPP skeleton as a target skeleton. Name the new animation blueprint arms _ NMBP. NMBP. And let's open up the blueprint editor. Okay. Interesting. Okay. And off to the right, we also have our details pane and an Anna preview editor and asset browser. Okay. So in the corner, we have a little preview cam. Interesting. Cool, cool. Adding state machine transition variables. In the My Blueprint tab, click on the Add New button and select Variable. Okay. Variable. And make the variable a Boolean. Red is Boolean. And name it isRunning. In the My Blueprint tab, already over here, click the Add New and New Variable and make it a Boolean, which it is by default. for now at least, and say is falling. You should now have two animation transition tables that will drive the animation state's machine. That will drive the animation's state machine. Excuse me. Okay. And also, if we click on the variable, it pops up over in the details pane, so we can edit some of those details of each, I guess, little property on the left. Okay. So now we can move on. Step 2, setting up your event graph. During this step, we're going to edit the animation's event graph to ensure that our animation transition variables are firing properly while the game is running. Updating your state variables. Open the event graph by double-clicking on Event Graph in the My Blueprint tab. Okay, that's right over here. Right-click in the graph to bring up the context menu. Type Update in the context menu search field. Update. Then click on the Event Blueprint Update animation. And here it is. Is that one already there? I think it was. To add that note. The note here that says, the Event Blueprint Update animation node allows us to update our state variables every time the animation updates so that they are always in sync with the game state. Okay, right click in the graph to bring up another context menu. And type owner in the context menu search field. And then click on try get pawn owner to add that node. Here it is. Draw off the output pin and select cast to character from the context menu. So we're going to drag off the output pin and place it in empty space. And we're going to type cast to character. Just right here. Number 7. Wire the output execution pin on the Event Blueprint Update animation to the input execution pin on cast to character. So we'll take this, place it right down here. Number 8, drag off the as character output pin and select get character movement. As character and get character movement. So now we have that over there. That looks good. Drag off the character movement output pin and select get movement get movement mode. Get movement mode. Right here. Querying character movement. Drag off of the movement mode output pin and select equal. We want the enum version of equal. Determining if the character is falling. Set the drop-down value on the equal enum node to falling. And falling. Alt click on is falling in the My Blueprint tab and drag into the graph and drag into the graph to create a set is falling node. Connect the unlabeled output execution pin of the cast to character node to the input execution pin of the set is falling node, and connect the output boolean data pin of the equal enum node to the input Boolean data pin of the set is falling node. Alright, so first up is the cast to character. And we want the empty one. We'll take this and it's going all the way over to that new set function. So now it's connected there. And now we need to connect the output Boolean data pin right here to the equal enum node. Like that. Okay. So from what I can tell, so we're getting a pawn owner. We're the owner of the pawn. And we're going to cast that actor as a character. And then we're going to get the character movement to get the movement mode, which is going to be one of these modes. And we use a constant falling option to see if falling is equal to the current movement type. And if it is falling, then this will be set true. And it'll set the variable is falling to true. Okay. Determining if the character is running. Go back to the cast to character node and drag off the as character pin again. This time select the get velocity node. Instead of doing character movement, we're going to do get velocity. Right down here, get velocity. If the character is not standing still, the length of its velocity vector will be greater than 0. Right. So drag off the return value vector output pin and select vector length to add that node to the graph. Okay. Vector length. Let's move these down a bit. I'm actually going to move these away to a different side. So now that these are on the right now, just so we have more room to work with on the left. Alright, so now that we have vector length, so we can tell if our character is moving at all, drag off the return value, float output pin, and select the greater than node. Float is greater than float. Okay. I'll click on is running in the My Blueprint tab and drag it into the graph to create a set is running node. Slash connected there, and this is connected here. Sure, that's good. So now we've done all of this. Your event graph should now look like the following. So if we zoom out, it looks pretty much the same. Yeah, I think we've got everything covered. So we're just checking to see if vector length is greater than 0. Right, okay. That seems all Good and dandy. Let's move on. Adding an animation state machine. During this step, we're going to put together a state machine that will take advantage of our newly made variables. Double-click on Anim Graph in the My Blueprint tab to open it. So that was the other tab over here. Right-click on the graph and select State Machines. Scroll down. State Machines. Add New State Machine in the context menu. Right-click on the New State Machine in the My Blueprint tab and name it ARMS State Machine. So let me show you what's going on over here. I'm gonna click on this over here and rename it to ARMS State Machine. Connect the output execution pin on the ARMS State Machine node to the result input execution pin on the final animation pose node. So we're selecting it on the other side over here. Just gonna hook it up like that. Okay, double click on the ARMS State Machine node to open up its graph for editing. So now you can see up here it's changed to ARMS State Machine. Let me just save it so we don't lose any of our progress. Alright, step 4, adding animation transition states. During this step, we're going to add 5 states to the graph, namely idle, run, jump start, jump end, jump loop. So right-click in the graph and select Add State from the context menu. Name the state idle. Just move it. Double-click the state to begin editing it. There's a whole state. Okay. So now our tab name has again changed. So it represents idle and it's a state. You can see like the hierarchy of graphs that we're setting up at the top here. Idle is over here. Firefox, go away, please. Idle is right here. So click on Play FPP _ idle to insert node. Oh, we're context menu first. Then we type in idle. So that's our idle animation. Connect the output execution pin of the Play FPP _ idle node to the result input execution pin of the final animation pose node. So repeat steps 1 through 6 for the other 4 states, namely run, start, jump end, and jump loop. Alright, so let's go back to the ARM state machine. Add state, run, open up run. We'll type in run. We have our animation up here. We'll connect them and we'll go back to here, add state, jump start. Open that up. Jump start. Connect. Back to the ARMS state machine. Add state, jump end. Insert animation node. Finally, jump loop. Okay. When you are done, the ARM state machine graph should look like the following image. Let's go back to the state machine. And they want us to kind of organize it so it looks a little bit better. So let's do that. So now we've kind of separated out our states. That looks just fine. Okay, now that looks good. Let's save that. Alright. Each state should contain their play node connected to a respective final animation pose node. Drag a wire from the entry node to the idle state node. Okay. .4.1 Add idle to and from run transitions. During this step, we're going to set the idle to and from run transition so that when your character starts moving, the state machine will transition from idle to run. So drag a wire from the idle state to the run state to create a transition. Okay. Double click the transition to edit it. This is starting to get deep. Control click on is running in the My Blueprint tab and drag it into the graph to create a get is running node. So here we are, we have our big state machine over here. Let me just minimize that. And we're going to grab the is running node. So control click is a short way to get a get variable method. If you don't control click, it's going to ask you, do you want to get or set? So you can either, if you look at the tooltip, it says control drag to automatically create a getter. Likewise, alt drag to automatically create a setter. Otherwise, you can drag it straight from the My Blueprint and choose from that little menu that pops up. So let's connect that. When your character stops moving, the state machine should transition from the run state to the idle state. So let's return back to the state machine and drag a wire from the run state to the idle state. Okay. Point it back. Double click the transition to edit it. Control click on is running in the My Blueprint tab and drag it into the graph to create a get is running node. Here we go. Drag the output of the Boolean pin and create a not Boolean node. So we're going to drag it off into the empty area. I'm just going to type in not Boolean. So there's that logic, and then we'll put it here so that when we're not running, we can enter the transition. Okay. Add idle to jump start transition. During this step, we're going to set the idle to jump start transition. Head back to the state machine. So idle to run is all good. Now we have to do from idle to jump start. We're gonna edit that transition. We have the is falling node, and when we're falling, we can do the jump start. Simple enough. And then the run to jump start transition. So drag from run to jump start. Edit the transition. Control click on is falling to create a getter. It'll be the same case where if we are falling, then we will enter the jump start. So now we're doing the jump start to jump loop transition. So I'm bring that over here. Go ahead and create that transition. It's very specific about where you want to drag it to. There we go. Now we want to right click in the graph and search for time remaining for FPP underscore jump start. So click on this one, give it some room, and we're gonna drag off the output and grab the less than equal to. So we place that one down there. Just gonna add the input to check if it's less than or equal to 0. Then we can enter in this transition from jump start to jump loop. So basically when the jump start animation is finished, then we can enter the jump loop. So the jump start is just, you know, a startup animation that'll last a finite amount of time. Then the jump loop can probably loop indefinitely until we end the jump. Looks like we want to put in a variable or 0.01 right here for step 5 in the other output field on the less than or equal to node. So I guess when it has 100 milliseconds left on the animation, then we can enter the transition. I wonder if that means like there's some time needed to finish the transition or not. Anyways, now we can add the jump loop to jump end transition. So let's edit the transition. And we're going to get is falling. And we want to say when we're not falling. That's not what I wanted. So when we're not falling, we can enter the jump end transition. So now back to the state machine and add the jump end to back to idle transition. Let's edit the transition again. I think for final time, I'm going to look for the time remaining. Since jump end is not a infinite animation, it's a finite animation. So again, we want the less than or equal to node. Hook that up, and again we're going to put in 0.1 seconds or 100 milliseconds, and then connect that output into the can enter transition input. So that wraps that up. Now we need to associate the animation and character blueprints. During this final section of the tutorial, we're going to associate the animation blueprint that we created with our character blueprint. So let's compile and save this. Now we can close it. Navigate to the blueprints folder in the content browser and open up the blueprint for the FPS character. Let me enter the enter the open full blueprint editor link right here. All right, select FPS mesh in the components tab. set the animation blueprint for the FPS mesh to the arms_anim blueprint we just created. Okay. So is it down here then? Arms_anim blueprint. That seems correct. Let me just double check to see if there's anything else that I'm missing. No, that seems to be the right property to set. Yeah, I think so. Okay. So while you're in the defaults mode, change the FPS mesh transform to 50, -15, -150 for location, and this for rotation. And over here, let me move that over here actually. So location for FPS mesh is 50, -15, -150. And for rotation, we have 0, 25, and 350. Compile and save the blueprint before closing. Compiled and saved. Click the play button, and we should see this happening. That looks about right. So now we have our arms set up like as if they were holding a gun. And they move when we're walking, or rather running. When we jump, they move. They transition from jumping up and hitting the ground at the right times. Or if you just jump up and don't hit ground, then they're just gonna sit there. Alright, sounds pretty good. Uh-oh, what have I done? Do I want to click on that? There we go. Right. Okay, so that finishes up this part of the tutorial. We've set up a project, implemented a character, implemented a projectile, and animated a character. So I guess that's the whole thing. That's the whole FPS project. That wrapped up quicker than I thought it was gonna. Okay. I'm trying to click on this thing and nothing's working. Okay. Guess that means we're done here. Yep, there's 4 sections. Alright, let's go back to the programming tutorials. I think that's it I want to do. Well, I've done all the beginner tutorials, and I've done 2 of these. I've done the components and collision already, and I've done the player controlled cameras already. I haven't done the user interface with UMG yet. I may do that later, but I think I want to try to look for blueprint guides. I think this is all stuff that we don't really need to mess with right now. Blueprints visual scripting. Let's try this out. Alright, the Blueprints visual scripting system in Unreal Engine is a complete gameplay scripting system based on the concept of using a node-based interface to create gameplay elements from within Unreal Editor. With many common scripting languages, it is used to define object-oriented, or OO, classes or objects in the engine. Don't know why I said that weird. As you use UE4, you'll often find that the objects defined using Blueprint are colloquially, I can't say this word. I know I can't say this word. It messes with me every time. Colloquially referred to as just blueprints. Colloquially. Yeah, I've got it. This system is extremely flexible and powerful as it provides the ability for designers to use virtually the full range of concepts and tools generally only available to programmers. In addition, blueprint-specific markup available in the Unreal Engine C++ implementation enables programmers to create baseline systems that can be extended by designers. So we've seen some of that implementation work done in those tutorials. And we've like extended our own C++ classes into blueprints, which was pretty interesting. Let's check out the quick start guide. This quick start guide will walk you through building and acting the level with different components, then turning it into a blueprint class you can add launching behavior to, so your character will fly around the level. Making it into a blueprint class also means you can create as many launch pads in your world as you want, just by dragging into the level from the content browser. What's a launch pad? Just checking through this blueprint to see if it's just a little bit too easy, because a lot of the stuff we already went through during the programming tutorials. Launch character, test the overlapping actor. You know what, let's get this try. So we're going to create a new project. So new project. And there's a template we can use. The side scroller template, but it's in 3D. That seems like a just dandy. Just kidding, I don't want it there. On the C drive, I have a section for game dev, projects. Okay, and we're just gonna name it Blueprint Quick Start. Just kidding. So you can see, this is what our little preview window looks like. I think I'm just gonna name it messing with the window size, hold on. Good. Just gonna name it Blueprint Quick Start. That's the name of this guide. Just loading up. I don't know if we'll need this solution, this disco solution. Now that we're moving on. Anyways, we can select the side scroller template in the blueprint tab of the new project window or new project wizard. So we've done that. We've oh, did I do this? Uh-oh. I guess we'll see if the starter content was included. Huh. Well, I guess now we just have to wait for it to pop up. And I have no idea how long that will take. In the meantime, let's look at what other, I guess, tutorials they have. Let's read this introduction. The Blueprint visual scripting system in Unreal Engine is a complete gameplay scripting system based on the concept of using a node-based interface. Right, I think we've read this already. Seems to have related to some previous system that they've implemented before. In their basic form, blueprints are visually scripted additions to your game by connecting nodes, events, functions, and variables with wires. It is possible to create complex gameplay elements. Blueprints work by using node graphs of nodes for various purposes, object construction, individual functions, and general gameplay events that are specific to each instance of the blueprint in order to implement behavior and other functionality. And there's commonly used blueprint types, level blueprints, and blueprint classes. I think so far we've only messed with blueprint classes. But then there's also blueprint macros right here and blueprint interfaces. I don't think we've ever messed with those yet. So the level blueprint fills the same role that Kismet did in Unreal Engine 3, don't know what that is, and has the same capabilities. Each level has its own level blueprint, and this can reference and manipulate actors within the level, control cinematics using matinee actors, and manage things like levels, streaming, checkpoints, and other level-related systems. This level blueprint can also interact with blueprint classes. Blueprint classes placed in the level, such as reading, setting any variables, or triggering custom events that they might contain. The blueprint classes are ideal. We have Unity ready, or not Unity, Unreal Engine. And why does this look weird? Oh, there we go. This doesn't. I want list. There we go. So we did include the starter content. Good. Create customizable prefabs with construction scripts. Interesting. A playable game character. A HUD. Cool. I think it'd be nice to control a HUD with blueprints. That might be easier than programming. We'll have to see. Okay. So let's start with this quick start guide. So now, yes, we do have the side scroller up and loaded up. We have our little actor, pawn, character guy. And we have our level set up. Good, good. So, moving on to step 2. Construct your launch pad. You'll first build the launch pad in the level editor and then convert it to a blueprint class so you can add your gameplay behavior to it. So first move around until you're looking at the top platforms in the level. Okay. It's right there. We are going to create the container to hold all the parts of our launch pad by using the empty actor. The two parts or components you will need are a shape to represent the launch pad and a trigger for when the character overlaps it. So in the modes panel, click on basic, then find the empty actor. Basic, and then empty actor is the first one. Drag it into the level so that it is sitting on one of the top platforms. Hold on. Where'd that go? Okay. That seems just fine. Maybe. We'll try to match what they're doing on theirs. So we have it kind of towards the end of this one. Place it down a little bit. We kind of slide it in that way so it's kind of in the center. That looks pretty much in the center. Close enough. So, now that you have the actor selected in the level, its properties are visible in the Details panel. At the top of the Details panel, you can rename it. Go ahead and click in the box to enter a new name, like Launchpad. So instead of actor, we're going to name it right here with Launchpad. That sounds good. Now renamed, the first component we're going to add is a cube. Although we will scale it down a bit to make it more platform sized, adding this component first makes it the root component. So all other components will follow its lead for position, scale, and movement around the scene. Oh, you can't see this right here. Around the scene. You can rearrange components as you work as well. So this is not a permanent decision. In the Details panel, click the Add Component button, then select Cubed under Basic Shapes. So here's Cube. Let me shore that up. We don't really need so many folders open in our outliner. So now I can scroll this down so I can see our component list. Now you should have the cube component selected. Yes. And it's visible right here. So you can tweak its properties. Resize the cube to 110.1. So the Z is scaled down to 10% of its original size, 0.1. Let's make sure that the launch pad is actually at the right height. Let's set the position grid snap value a little bit lower. Let's try 5. That seems pretty good. Maybe something like that will work. And I think we need to move it this way. So now that seems pretty good. Good enough for our purposes, I suppose. Alright, now we will add a box collision component, which will fire off an event whenever something overlaps it. In the Details panel, click the Add Component button, then select Box Collision under Collision. So we're clicking on Add Component, going down to Collision, Box Collision. Just going to rename it to Collision Box. And we're going to resize the box to be the same size of the platform in X and Y, and extend it a bit above the platform in Z. If you want to enter in your scale directly, try 125, 1.25, and 1.5. So now it's pretty close to the edges. Just wondering if there's a way to move slowly in the editor. I don't think there is. So let's just reduce our camera speed. So we're going to be a little bit more accurate. So that looks pretty decent. Launchpad, collision box, yeah. That looks decent. So if at any time you need to change your actor's properties, such as scale up the whole launchpad, you can click on Launchpad Instance right under the Add Components button in the Details panel. Now that you have your actor the way you want it, we will turn it into a Blueprint class. You can add more components inside the Blueprint editor and tweak them just like you can here in the level. Okay. Hold on, I gotta stand up real quick. Gotta make sure you stretch. Don't sit down for too long, folks. Oh boy. All right. Making changes inside the blueprint means excuse me, means that each time you make a new launchpad, it will have the look and feel you have created in the blueprint editor. While you could duplicate your launchpad actor around the level, any changes you make on a particular launchpad would only affect that one copy. In the Details panel, click on the Blueprint Add Script button. So we can do that right here. And I'm going to expand the folder with Side Scroller BP and select the Blueprints folder. At this point, you can rename your blueprint or leave it as a default Launchpad _ blueprint. I'm going to stick with the standard of saying BP _ and then the name. That seems like a pretty good standard to have, so that when you're looking at multiple files together in one folder, you can sort by letters, and you could, you know, see all your blueprints together, then all your levels together. So we've created the blueprint. Your blueprint is now visible in the content browser. Right now you could drag and drop from the content browser into the level to create lots of copies of your platform mesh and trigger, but there will not be any behavior on it yet. In the next step, you will start setting up the graph nodes inside your blueprint to launch your character when it crosses the platform, or crosses the launchpad. Okay. Create your starting point. To start adding behavior to your blueprint class, you will need to open it in the blueprint editor. Double-click the blueprint class in the content browser. It's already open. And now we can see, you know what? Yeah, I probably should have put it below the box. Oh, it says right here. Excuse me. Got something in my throat. At this point, if you just adjust the box component's placement, it will be applied to all launchpads you make from this blueprint class. Just like when you were working with components on your launchpad actor, you can select the box component in the components list and adjust the location. Try location of 0050. So it's a collision box. Move the Z up. Move the Z up over here by 50. That looks okay. Should we scale it down a bit, do you think? 1.25. Move down to like 45. Let's try 40. That seems okay. Like that. I'll just compile and save it right now. Alright. Docked next to the Viewport tab is a construction script tab and an event graph tab. right over here. Since you are going to be creating gameplay behavior, you should start with the event graph. Click on that tab now. So we've seen this before. Events are the starting point of your blueprint graph's execution and can be associated with a number of different gameplay situations. A selection of the most commonly used events are visible right away, seen as translucent event nodes. Though certainly useful for many of your blueprint graphs, we will be making one of our very own. We want an event that will execute when anything overlaps our box component. First, select the box component in the Components tab. So I name my collision box. Right-click it in the empty spot in your graph to bring up the context menu of nodes you could add to the graph. We are adding an event for this component, so expand the Add Event box. Add the event for collision box, that is. And then collision. Select On Component Begin Overlap. On Component Begin Overlap. Okay. So that's a big old function. Your graph now has an On Component Begin Overlap node. Any nodes connected to this event will execute when something overlaps the box component of your launchpad. In the next step of this quick start, you will begin connecting nodes to the output pins of this node, and learn more about working with nodes in blueprints. Okay. Test the overlapping actor. Right now, that On Component Begin Overlap event will execute when anything overlaps the box trigger. So, since an event, let me put it down below the other events. Okay. Good. We only want to actually execute our launching behavior though if the overlapping thing is our avatar or pawn. Think of it as asking, is the actor overlapping the box trigger the same actor as our pawn? We will do that by working with the other actor output from the On Component Begin Overlap event. So we'll grab the other actor. And what are we searching for? So again, for those that don't know, the context menu is adaptive. So when you drag a pin off an output, it will only search for the compatible nodes for that output pin. So type equals into the search box. Easy enough. And we will say equals object. We could set side scroller character as the other input to the equals node, but then if we change the character we were using, we would need to reopen this blueprint and manually update that. Instead, let's get a reference to the current pawn we are using. So right-click in the empty part of the graph to bring up the context menu and type pawn. So we're searching for pawn in the search box, then select Get Player Pawn under Game. Right there. Seems a good a place as any to place that. So connect the return value output on Get Player Pawn to the second input on the equals node. And I believe player 0 is just fine for us. Now that we have got a node that will tell us if the other actor is a pawn our player controls, we will use the answer to change the execution flow of our graph. That is, we will direct the execution flow as it leaves the On Component Begin Overlap node. For that, we want to use a flow control node, specifically the branch node. Drag off of the execution pin on the On Component Begin Overlap node and release an empty part of the graph. Okay, let me just scoot it over here so we have more view of it. Type branch in the search, then select branch from the context menu. Interesting. Let's bring this down here. like that. And then we're just going to connect the equal output of the equals node into the condition input node, or pin, input pin of the branch node. Trying to get all these terminologies correct. So we've done that, and it looks like that. The graph is now ready for you to set up different behavior to execute depending on whether the overlapping actor is your pawn or not. In the next step, we will do just that and set up the blueprint nodes to launch our character if the results of the equal comparison is true. Launch our character. Our launchpad is going to work by using a function called launch character. The launch character function adds the velocity you specify to the character's current velocity, allowing you to throw it in whichever direction you like. It only works on characters though, so we need to make sure that our pawn avatar is a character humanoid avatar. We do this by casting. Casting attempts to convert your input into a different type, so you can access specific functionality that is only allowed for that particular type. It will succeed if your input is based on that type. Everything you can place in your level is an actor, in addition to any other specialized behavior added on later. That means you can get a reference to anything in your level, cast it to actor, and it will succeed. However, not everything in your level is a pawn representing you in the game, so casting something to pawn may or may not succeed. Drag off of the return value pin of the get player pawn. So we're just going to add a new node, and again we're going to cast. We want to cast to character. So drag off of the as character pin onto the cast node. We've done that. Now type launch and select the launch character in the context menu. Launch, and let's try that again. There we go. So now we have that. Notice that the output execution pin for successfully casting automatically connected to the input execution pin of the launch character. So while we created this one, it automatically created this white one. Type 3000 into the Z field, the launch character node. Finally, wire up the true execution pin of the branch node to the cast character node's input execution pin. So the cast a character and the launch character only care if the overlapping actor is our pawn. Let's do something like that. And then in this case, I'm going to drag these out so it looks much better. So it looks something like that. Let's drag that up. It looks much better. At this point, compile and save the blueprint. Sure thing. Drag several of the launch pads into your level from the content browser. So now you can see, since we clicked on add blueprint script from this one, this launchpad is already a BP underscore launchpad. So we don't need to mess with that one. But we can add on other ones. So we can put one like right over here maybe. That looks good. Maybe we'll put one up here too. Let's see. what will happen if we rotate it? Need to rotate that better. I'll put 5 degrees on. There we go. And we need to move it over better. And I'm gonna sink it into the ground a little bit. And let's do that again over here. Something like that. Let's try to play this. Holy cow. That's a bit much, don't you think? Yep, that's a bit much. So that was too much, I would think. Let's not launch that much. How about 1200? We'll compile and save that. Save this. And we will play it again. That's much better. Cool. Kind of acts weird when you land on it, but neat. So we could try to play a sound when your characters launch using an audio component. Let's try to do that real quick. Audio. Play sound at location. And location is going to be our actor. So we'll say something like get actor location. So the target is self. What's the sound going to be? Starting music. This is an actual music. It's 47. Starter birds. Starter background cue. How about wind? Let's see what that does. That sure is wind. But it's like the full clip. Alright, what can we do with this? What can we do with sound? I don't know. Audio. Huh. Can we change this to a different one? Let's try to do the spawn sound. I want to see what the difference is with that. Sound at location. Sound will be... how about explosion this time? Something shorter. Same sound settings again. Is there anything that we can do with it to manipulate the sound right here? Effects, components, particle system. No. Alright, let's just try that out. I mean, I guess it works. We can create a variable to store our launch velocity. Variable to store our launch velocity and expose it so we can set it on each copy in the level. Or we could add a particle system component to your blueprint and use one of the particle systems from the starter content. Let's try that out. Spawn emitter at location, and well, why not? We'll just use the location again, and we're gonna use the explosion. Auto destroy. Yeah, that seems good. Compile, save. Let's turn the volume down on this sound. That's good. All right. Can we this camera? Spring arm. Target arm length. Can we zoom that out? Let's try that out. Much better. So now this is like as if you're jumping on like cars and you're blowing them up to propel yourself up in the air. Like that would be the game mechanic here. Cool. Now we could add an arrow component and use its rotation to define the direction to launch the character. Huh. Using timelines, add some animation to the box mesh to represent it launching the character. I don't know what that is. Maybe not. We'll probably pass on that. Okay, let's go back. Basic scripting. Huh. What does cheat sheet show? Cool, cool. Just some hotkeys, some ease of use things in here. Huh, cool. If you are new to Blueprint visual scripting in Unreal Engine 4, these Blueprint how-tos provide information on core aspects needed to work with blueprints, including creating blueprints, adding and connecting nodes, creating variables, and others as seen in the tables below. So I don't think we need to do this at all. That seems pretty easy. This stuff maybe a little bit more we can work around with, and a lot of this stuff I would like to see. So I guess we can start with setting get actor reference. Seems to be one tutorial. All right. By establishing reference to an actor, you can access his properties, variables, events, or functions, if applicable, during gameplay through Blueprints or C++, and alter them to suit your gameplay needs. Say, for example, you want to turn a light on. You want a light to turn on, rather, when a player enters a trigger box. Having reference to the light and the trigger box will allow you to do so by tying the light actor to the onComponentBeginOverlap event of the trigger box, in which case you could turn on the light. Getting proper reference to an actor is also important for communication between actors, as incorrectly specifying a reference will result in failed communication and undesirable results. Follow the steps below for an example of setting and getting reference to an actor. For this example, we are using a new Blueprint third-person template with starter content enabled. Alright, let's just make a new project then. Well, do we have to? You know, it'll just be easier if we just do it. All right, new project. Third person with starter content. Maximum quality, I guess. Game dev projects. We'll name it BP third person. Okay. So we have to wait for that to load up. But we're gonna draw or drag a box trigger into the level. We're gonna use this trigger to trigger movement in another actor in the level. Okay, we're at 35%, 39%. Let me switch up the music. There we go. %, come on, let's get going. It's currently stuck at 93%. I'm gonna close Visual Studio. I don't think we'll need it right now. Unreal has started up. See you, Garrus. So let's just put a box somewhere in here, I guess. That's really all there is. This is a third person starter stuff, really? Let's see what starter map looks like. Oh no. Let's not, I guess. We'll go back to minimal default. They don't really specify what they're doing. And I'm pretty sure I clicked the third person template. Huh. Let's just scale that out. Can I scale that out? No, it's pressing the wrong button. Let's just move it over here. Something like that. What's going on here? Let's just put a character in here. And let's play just to make sure. No, what? I don't seem to know what's going on. What the heck? What is this? This is the default pawn. I want to be the character, but where's the character? What the heck? Well, can I at least be like a cylinder? Let me see if I can automatically inherit the input. Somewhere around here is things to do. Rendering tags, holy crap, activation, cooking, character movement. No, movement, 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 movement. Holy cow. Right, so in the movement component. No. My god, there we go. Auto possess player. Player 0. It doesn't come with any logic in it. Alrighty. So let's just not do that. Can't undo any further. So let's just more, delete this character. So now we're just the floating ball. Sure. Okay, from the modes menu under basic, drag a box trigger. Box trigger. right there. In the details panel, for the box trigger, select the convert to class blueprint option. So we're just going to click on this, BP trigger box. Okay. So in the blueprint editor, under My Blueprint, click the Add Variable button. Add variable, and so click on the variable, and we will give it a name. What's the name? So it says it wants us to be. Okay, hold on. Let's move this over here. So we want to switch it from a Boolean to an object type, actor, reference. And so here we are specifying that the reference is of the actor type and is an object in our level. Okay. Name the variable target actor. Good, and click the editable checkbox. So this indicates that the variable is set to public, which allows it to be accessed and set outside of this blueprint via the details panel in the main editor window. This is useful in situations where you want to modify the variable without having to go into the blueprint to modify it. You can also enter in text to appear as a tooltip for what the variable does or is intended for. So we'll just put in the tooltip that they have, the actor to target. Target. Here we have entered in the text the actor to target. Click compile and save. Minimize the blueprint and return to the main editor window. Then select the box trigger blueprint in your level. It's already selected. Let's build the lighting so we stop getting that error in the top left. In the details panel for the window, you should see under default the target actor variable tooltip. Right. And building has finished, I think. Building, and done. All right. So, under default, the target actor, variable, and tooltip, the actor to target. Good. From the content browser, under content, back over here, Firefox, and content, starter content, shapes, add 3 shape cubes to the level. Yeah, it looks like they have definitely a different template that they've used here. Maybe I didn't select the template and maybe I just selected some random third person thing. Shape cubes. It's 1 cube, 2, and 3. Whatever you add to the level in the details panel for each actor, set their mobility to movable. Move Firefox over here. A lot of moving. So cube number 1. Set mobility to movable. Pretty sure this is movable. Movable, yes. There's 1. There's cube number 2 and number 3 movable. This will allow us to move them via blueprint script. click on the box trigger blueprint in the level. I'm having a hard time clicking on it. There we go. In the details panel, click the none box under the target actor and search for shape, or the name of the actor is added. Okay. So when clicking none, all actors currently in the level are displayed. However, we're going to target one of the cubes that we've added. Let's go for shape, or cube number 2, I guess. Oh, it's showing us something else. Click the eyedropper icon right over here next to the magnifying glass icon. So this will allow us to select an actor from the level as the target actor by clicking on it in the viewport. So if I say cube number 3, pops up cube 3. Move the eyedropper over one of the cubes and click it to make the target actor. When you select an actor, the target actor variable will update with the selected actor in the details panel. Here we have set reference to an actor, which will be our target actor. Open the box trigger blueprint, then in the My Blueprint window, click the eye icon and enable Show Inherited Variables. My Blueprint window, go to here, Show Inherited Variables. So now we have a lot more stuff in here. What was the third option in there? Show replicated variables only. Okay, interesting. This will allow us to add events on the components that we were inherited. That were inherited. Sorry, my brain just fried right there. When we first converted the trigger box to a class blueprint. Under trigger base, right click on collision component. Right click and then choose add event. Then add on components begin overlap. Okay. Interesting. And then choose, well, this will create a new event node on the graph. Hold control and drag the target actor variable into the graph. So I add a getter for this. This creates a get node, which will get whatever is assigned to the variable when we have set which we have set to an actor in our level. Drag off the target actor node. Search for and add an add actor local offset node. So move Firefox over here. Now we have more room over here. Actor local offset. Good. This will allow us to add to the current target's transform, allowing us to move it from its current position. Connect the nodes as shown below and set the Z value on the add actor local offset node to 500. Like that. Okay, this will get the target's current location and move it up by 500 along the Z-axis whenever the trigger box is overlapped. In the Components window, click Trigger Box Blueprint so it is selected. Components, Trigger Block Blueprint, right there. If you do not see the Components window, you can enable it from the window menu option. In the Details panel for the trigger box, under Rendering, uncheck